Good evening. We're starting with pages 21 through 29. Looking at a different concept than the last time we were on here, and at the same time, the same concept, linear and quadratic regression. If you aren't sure what regression is, it's describing a way to measure the relationship between two variables. So this usually starts with data that is plotted. It creates a scatter plot, and you can use that scatter plot to look for trends, make predictions, look into the future, anything like that. What I did with the notes was I wrote in here how to type everything in by hand on a Desmos calculator in order to be able to access the regression feature of it. So if you were going to have to do that, you would start with Desmos and follow these instructions. You can see here that there's a couple different options based on what the data looks like when you plot it, but the way that I'm going to have you do this is much easier than having to write this in there from scratch. So I'm going to give you an example here where there is a linear regression situation. That means that when you plot these points, the trend looks like a line. When you plot these points in Desmos, Desmos is going to have a box that looks like this, and each of the pieces of information in the box tell you something about your data. They give you a scientifically created trend line, and they tell you what the slope is and what the y-intercept is, and you can then take that and write out the linear equation that represents the trend line. So it's kind of interesting, and the best way to be good at this is to give it a try. I have some examples here that we're going to go over on page 24. But before we do that, I wanted to show you where you can find the links that I created that will make it easier for you. The module that we have down here in the corner, if you go to this module, it will bring you to 3 links that I've provided, 2 of which we will be looking at today. These links will bring you right to the exact kind of version of the Desmos calculator that you would need. Notice that at the top, this one says linear regression, and then the next one says quadratic regression. That just means that one of these is used if your trends look linear, and one of these you would use if your trends looked like they were arcing, or they made a smile or a frown. That would make it a quadratic type regression. So let's look at some examples. The following data were collected about students' study time and the grades on their exam. This is the data right here. We are going to enter this data into the first calculator. I'm assuming that this is probably going to be linear, but if I put it in there and I think it looks more curvy, like a smile or a frown, then I will switch and use the other version of the Desmos calculator. So let's zoom out just a little bit here. I don't know if I can look at both of these at the same time. What I'm going to do is probably just make a picture of this. Let's just make a picture of this. Copy. Oh, that was so clever. Oh my goodness, that was very, very clever. I wasn't expecting that to do that so quickly. Okay. So I'm going to go and use this browser. This is actually an active browser window. And I'm going to put in here all of those numbers. 2.3. I'm going to actually pause this and put these numbers in. So I'll be right back. I have all of these in here now. Things to notice. If you want to be successful, you have to have the same number of elements in both of your columns. So they're ordered pairs, they all need a mate, so make sure it's a thing. The next thing to notice is, because of the way this is set up, it's showing me all of the dots that we created the scatter plot, but then in the second line, there's already a call for creating the information you would need to know the line of best fit. So the line of best fit is y equals mx plus b, with my slope and my y-intercept found for me by the computer. So I'm just going to take this information and I'm going to bring this back to my notes. So let's go back over here. Let's take this and go back over here. This is the information that we just found, so I can write it in my notes. It says, what does it say? Is it linear? Well, we can come to the conclusion it does look like a line, so we'll say that the data looked linear. They want the equation of the line or curve of best fit, y equals 5.44684x plus 69.755595. And you can see that I got those from right in these two spots, the information window on Desmos. It also says, if you study for 3 hours, what grade would you expect to get? Now remember, when we have a table, the first column is going to represent the x-axis and the second column is going to represent the y-axis. They gave us an x value and they want us to find out what the trend line says for the y value. This is where x equals 3. So I'm going to go back to my browser window and I'm going to use the calculator to help me with this. I tap on this. It doesn't want to react. Come on. Let me see if I can get this to react to me. Might have to, hold on a sec here. I had to pick a different tool. So I'm going to hit browse. Now we can react with this. We are looking for a y when x equals 3. So I'm actually going to type in here x equals 3. It's giving me a vertical line, and I'm just going to tap where it looks like they're intersecting. This says that according to my trend line, after 3 hours of studying, a student should get around an 86. We're using this trend line to try to extrapolate, to find information. And so 86 is the expected grade. I'm going to do this again. I've got this up right, so it's making me look like I can't write words. There we go. 86, right there. Okay, so knowing what we just did, one thing that I can give you a little bit of advice in is if you're going to start a new problem, just refresh your browser window instead of going through by hand and deleting everything. What a pain in the butt. So there, refresh. And now you're able to go ahead and make sure you're still in the linear regression window. You're going to do the self-practice, which is number 2. 2 is a self-practice problem. Number 3, we're going to look at together. So this is going to be looking at a snowstorm and how many hours into it, what that looks like weather-wise. I am going to go ahead and I am going to copy this and I'm going to bring this over to my other browser window. So I have 2 browser windows open right now. Now, why am I bringing this down by the quadratic one? I'm looking at my data here and I'm just noticing a trend that it starts in the 20s, then it dips down and then it dips back up. So that tells me that there's probably going to be a curve involved here, but you won't always see them. Sometimes you'll have to actually experience what it looks like before you choose which calculator you're going to use. I'm going to go ahead and pause this while I put these values in the calculator that I have for the quadratic regression window. I paused my video and I went ahead and put all of the numbers in from that third example. And now I'm just kind of zooming around here trying to find what looks like maybe a part of a vertical line. What I'm going to do is I'm going to change how my window looks. And how I'm going to do that is I'm actually going to go up here to the corner where we have this wrench. I'm going to touch the wrench and I'm going to change the videos to, or the video, I'm going to change the window settings. So according to my x-axis, it looks like I have units on here from 0 to 10. So I'm just going to put, or 1 to 10. So I'm going to put 0 to 12. Okay, that's kind of interesting. And then I'm going to look at the y-axis and see if I can fix that. Now, why is there connecting the dots when I've already told you I don't want to connect the dots? I can get rid of that if I go ahead and tap that next to the Y, there was a little bit of a thing here where you could look at that. I don't want to do it. So I'm going to take those off. I don't want to see the connect the dots. This is the trend line right here. Again, if I do want to see my dots, I can go ahead and there they are. Ooh, this was kind of cool. I have a drop down window where I can change it from quadratic regression to linear. That's pretty neat. Now, because this is showing a curve look, I can go ahead and use the information from this window mostly to answer most of those questions that we have. So I'm going to go ahead and copy this information and bring it over to my notes. Okay, let's see here. We'll bring this over here and we'll put it right on top of the self-help for now. This says, does this data represent linear or quadratic? We see a curve, so we're going to say quadratic. The line or curve of best fit is y equals 0.742424x squared. That's this. Plus, minus 8.11818x plus 35. I know I'm bleeding into the table here, but I'm feeling like I just want to keep on going with that. That second term is negative because this is a negative number. Then it asks us to figure out what the temperature will be at 12 hours. Notice hours is our x. So we're going to go in here and we're going to write x equals 12. X equals 12. There we go. X equals 12. I'm going to see where that on my graph, and that looks like they're predicting it's going to be 44.55. So we'll say approximately 45 degrees. Going back here. Approximately 45 degrees. Okay, this is our little spiel on regression. I'm going to come back in the next video and I'm going to start on page 25.